Let's see if we can interpret this Riemann sum. Maybe it would be smart to look at a specific n value. I think the numbers are going to come out nice if we pick maybe n equals 5. So I just plugged in n equals 5 into the sum that was given, and let's simplify. And let's write out the 5 terms. Starting at I equals 1, we get 9 plus 1 minus 1, that's 9 plus 0. And then we increase our I value until I becomes 5, and we get 9 plus 5 minus 1, that's 9 plus 4. Okay, I left this 1 out in front of this sum because this 1 represents the width of each one of our rectangles, while this number represents the height or the function value of each one of our rectangles. So clearly our function is increasing from 9 to 13. And if I was going to draw a couple of pictures of how to interpret this sum, one possibility would be that our function is 9 plus x, and our x values are ranging from 0 to 5. Our little rectangles would look like this. You'll notice that the width of each one of these rectangles is 1, and the heights of these rectangles goes from 9 to 13. And the area under this curve from 0 to 5 would be represented by this integral right here. But another way to interpret this Riemann sum would be to consider the function f of x equals x. If we took the width of each one of these rectangles to be 1, and we took x between 9 and 14, you could see that each one of the heights of these rectangles is 9, 10, 11, 12, and 13. So these rectangles in this situation are the exact same as those rectangles in that situation. However, these rectangles are approximating the area under a different function between the x values 9 and 14. If we took an infinite number of rectangles, that area would no longer be approximate, and our exact area underneath the function x between x equals 9 and 14 is what all of these rectangles would add up to. So again, that's a couple of different ways to interpret the same problem, and those aren't the only 2 ways to interpret this problem. So I'm going to back out of this so you can see the whole thing. And I'll go back up to the original problem and say that we can interpret that 5 over n as our delta x. And since delta x is b minus a over n, our b minus a is going to be 5. And you could see that from this problem. We had 5 subintervals of length 1, and that led us to an interval length of 5 in both cases. And then how you interpret this function here is really up to you. If this was a homework problem that you're turning into a teacher, either answer would be great. Of course, online homework systems are not always lenient. So try both of these and see if they both work. Okay, I hope that helps.